Hey, what's going on? All right, let's talk about Chapter 21, Populations and Communities. All right, so here's a cool picture. This was taken right down in Marcellus. And let's take a look. So organisms obtain food, shelter, and other things they need to live, grow, and reproduce from its environment or its habitat. So that's what a habitat is. It's where an organism lives, basically. It's where you can find them, where they get their food, where they move around. So take a look at this picture here. This whole picture itself could be a habitat. So for example, there's birds that fly all around. They catch fish out of that pond. They use the trees. But also you can shrink it down a little bit. So if you're talking about just fish, the fish's habitat is just going to be in the pond. Or you might talk about a population of ants that lives in a tree in the background there. So their habitat is just the tree. So habitats aren't like puzzle pieces where they all kind of fit together. They kind of overlap. So all the different organisms have different habitats, different needs, and it all kind of meshes together in an ecosystem. Now, in a habitat or in an environment, you have two types of factors. You've got biotic factors and abiotic factors. So biotic are the living factors. The prefix bio means life. Abiotic are non-living. That A in front of the word kind of means not, so it's like not living. So take a look at this picture here and try to list at least, let's say, 10 biotic and abiotic factors. Let's start with biotic. So in your head right now, see if you can list 10 living factors that you can see in that picture or you can imagine might be there. Maybe it wasn't in the picture when I took it, but you might see it there. So try to think of 10 right now. All right, what'd you come up with? So there's all different kind of trees there. There's cedar trees, there's pine trees, maybe some ash trees. There's different kinds of wildflowers maybe. There's different kinds of fish. Maybe a beaver would be swimming through there. Ducks I've seen land there before. All kinds of insects, birds flying through. So many different kinds of biotic factors in this ecosystem. Now think of abiotic factors. So what kind of things can you see in that picture that are non-living? That's a little harder. So maybe try to think of 5. All right, what'd you come up with? How about water? That's an easy one. It's non-living. It's a major factor. It's something all living things need. And air. Of course, air is made up of different things too. So it could be carbon dioxide, could be oxygen. What about the rocks? They're non-living. Check out that kind of mesh thing down in the bottom there. That's human-made. It's non-living. That's a non-living factor. We also include things like temperature. So temperatures are non-living factors that affect ecosystems. And also the weather maybe too is non-living, and that's a factor that affects. So maybe the clouds, maybe the wind, or soil if this was kind of in a forest. So those are the living and non-living factors. All right, good. Let's move on. All right, here's something called ecological organization. So kind of some fancy words here. You'll notice I kind of set them up to kind of start out big and get smaller as it goes on. So ecosystem is the biggest, and then community, and then population, and then species. So take a look at this picture. And let's kind of start at the bottom. So species is just one specific organism. So if I went into that pond and I scooped out a fish, it might be a brown trout, let's say, and that's one species of brown trouts, one organism. But I could also go through and try to catch all the different brown trout in there, and if I did that, that'd be a population. So population is all of the species in a specific area. So I would talk about the population of brown trout in that pond. I might talk about the population of turtles in that pond. Or population could be bigger. I could talk about the population of brown trout in New York State. So there's two things here. It's got to be a specific species, and it's got to be in a specific area. Now, this picture you might call a pond community. And when you do that, you include all of the populations. So you've got the populations of fish, of turtles, of insects, birds, plants, trees, birds that fly in. Anything that interacts in that pond is a part of the community. All living things. Now if we jump up to ecosystem, now we're going to include the non-living things. So in this ecosystem, we might call that whole big picture a forest ecosystem. And we're going to include the trees and the water and the fish and everything like that. But we're also going to include the soil, just different types of soil, the rocks, the air, the climate throughout the year is all part of the ecosystem. So that's kind of how it's organized, from smallest to biggest. So there's all kinds of ecosystems. There's forest ecosystems, pond ecosystems, desert ecosystems, coral reef would be an ecosystem. All right, let's move on. So here's a typical graph of predator and prey relationship. So you notice the prey, rabbit, is kind of going up and down, and so is the predator. But let's look at the timing here. So if we start here at the beginning, we see the population of rabbits is rising. So there's a lot of rabbits right now. Now, of course, fox eat rabbits. So if there's a lot of rabbits, then the fox are going to be able to get a lot of food. They're going to reproduce more frequently and have healthier babies. So their population is going to increase. Now check it out. Once their population increases and there's a lot of fox around, look what happens to the prey. So now the rabbits decrease. And of course, once the rabbits decrease and there's not a lot of them, the fox population is going to decrease because that's their food source. So they kind of chase each other, these two lines. So as the rabbits go up, then the fox go up. But as the rabbits go down, then the fox go down. So this is a real simplified way of looking at it, because obviously there's different predators out there and different prey and different food sources. But this is a good thing to understand for the next concept I want to get to. All right, here we go. Here is Yellowstone National Park. Never been there. It's a gorgeous place. Hopefully I'd like to get there sometime. But you'll see it's way out here in Wyoming. Okay, it's a pretty big park. Now, there used to be a very healthy population of wolves out there. You know, wolf is a beautiful animal. And wolves typically would eat deer. That was kind of their main food source. And that, you know, before humans got there, that's what happened. Is kind of a typical graph like the fox and the rabbit we just saw. As the deer population went up, then the wolf population would go up, and then they would also go back down eventually. But then people arrived. Okay, so people were scared of wolves. They thought the wolves were going to destroy their livestock. They thought the wolves were a danger to them, maybe to their children, and they were scared of them. So as a result, wolves were extirpated in 1926. Here's a funky word, extirpated. Think about that for a second. What do you think that means based on what I was just talking about? Kind of sounds like exterminated almost, and it kind of means the same thing. So extirpated means that the wolves were gotten rid of. Okay, they shot them. They destroyed the wolf population in Yellowstone National Park because they were scared of them. They thought they were hurting their livestock. But also the humans like to hunt deer, so they thought the fox were going to kill all their deer. So they thought it was a good idea. What do you think? Was that a good idea? I'm going with no. All right, so how did the extirpation of wolves affect the entire ecosystem then? Now, I just talked about deer. Obviously, if there's no wolves around, the deer population is going to increase, right? Okay, that's a direct result. But are the wolves being gone from that area going to affect any other organisms? Or is it just going to be the deer, you think? Think about that. All right, here's a cool video that talks about just what I was talking about, which is the effect of the wolves on the ecosystem in Yellowstone National Park.
One of the most exciting scientific findings of the past half-century has been the discovery of widespread trophic cascades. A trophic cascade is an ecological process which starts at the top of the food chain and tumbles all the way down to the bottom. And the classic example is what happened in the Yellowstone National Park in the United States when wolves were reintroduced in 1995. Now, we all know that wolves kill various species of animals, but perhaps we're slightly less aware that they give life to many others. before the wolves turned up, they'd been absent for 70 years, that the numbers of deer, because there was nothing to hunt them, had built up and built up in the Yellowstone Park, and despite efforts by humans to control them, they'd managed to reduce much of the vegetation there to almost nothing. They'd just grazed it away. But as soon as the wolves arrived, even though they were few in number, they started to have the most remarkable effects. First, of course, they killed some of the deer, but that wasn't the major thing. Much more significantly, they radically changed the behavior of the deer. The deer started avoiding certain parts of the park, the places where they could be trapped most easily, particularly the valleys and the gorges. And immediately those places started to regenerate. In some areas, the height of the trees quintupled in just 6 years. Bare valley sides quickly became forests of aspen and willow and cottonwood. And as soon as that happened, the birds started moving in. The number of songbirds and migratory birds started to increase greatly. The number of beavers started to increase because beavers like to eat the trees. And beavers, like wolves, are ecosystem engineers. They create niches for other species. And the dams they built in the rivers provided habitats for otters and muskrats and ducks and fish and reptiles and amphibians. The wolves killed coyotes, and as a result of that, the number of rabbits and mice began to rise, which meant more hawks, more weasels, more foxes, more badgers. Ravens and bald eagles came down to feed on the carrion that the wolves had left. Bears fed on it too, and their population began to rise as well, partly also because there were more berries growing on the regenerating shrubs. And the bears reinforced the impact of the wolves by killing some of the calves of the deer. But here's where it gets really interesting. The wolves changed the behavior of the rivers. They began to meander less. There was less erosion. The channels narrowed, more pools formed, more riffle sections, all of which were great for wildlife habitats. The rivers changed in response to the wolves. And the reason was that the regenerating forests stabilized the banks so that they collapsed less often, so that the rivers became more fixed in their course. Similarly, by driving the deer out of some places and the vegetation recovering on the valley sides, there was less soil erosion because the vegetation stabilized that as well. So the wolves, small in number, transformed not just the ecosystem of the Yellowstone National Park, this huge area of land, but also its physical geography.
All right, very cool movie, cool story. So all they did was they eliminated one species, the wolves, and you can see what a major impact that had on everything else, though, basically the whole ecosystem. If you remember a little while back, we talked about how beavers were a keystone species, and the keystone is that part that holds everything together. So you take the keystone out, like a beaver or like a wolf, and the whole thing falls apart. And it's very hard to predict in an ecosystem. You can't predict all these tiny little things that could happen. People thought it would just affect the deer, and it did, but it affected everything else as well. So a very cool story, and it's a cool story because they brought the wolves back, and things changed. So even though humans can destroy ecosystems, we can also fix them to a point. So kind of a cool story.